Hi everyone, welcome back. In this video, we are going to cover the top 50 Spring Framework interview questions covering all major concepts in a single video. If you are preparing for Java developer, Spring Boot developer, or backend engineer roles, then this video is going to help you understand and answer interview questions with confidence. In this video, we will cover Spring core concepts such as dependency injection, inversion of control, beans, configuration styles, and bean scopes. Then we will move to Spring AOP and understand how it helps in handling cross-cutting concerns. We will also cover Spring WebFlux for reactive programming. After that, we will explore Spring security concepts that are very common in real-world applications and interviews. And finally, we will touch on important Spring Boot concepts that simplify application development. We will take real interview questions and understand how to answer them step by step. The goal of this video is to help you think like an experienced developer and confidently handle real interviews. Let's start with the first Spring Framework interview question. What is the Spring Framework and why is it used? Spring is a lightweight, modular, and flexible framework for building Java applications. It simplifies application development by removing the need for complex configurations and tightly coupled code. Spring promotes good design principles like dependency injection and separation of concerns, allowing applications to be more maintainable and testable. Spring is widely used because it provides an ecosystem of tools for building enterprise applications. You get modules for web development, security, data access, messaging, caching, microservices, and more. The framework is non-intrusive, meaning your classes do not need to extend Spring-specific classes. This keeps your business logic clean. Developers prefer Spring because it makes application configuration easy, reduces boilerplate code, and integrates smoothly with popular technologies like Hibernate, JPA, and REST API. Its powerful container, AOP capabilities, and extensive ecosystem make it the standard for modern Java development. Next, what is IOC, inversion of control, in Spring? Inversion of control is the fundamental principle of Spring. It means that instead of your code creating and managing objects manually, the Spring container creates, manages, and injects them for you. This removes tight coupling between classes and improves flexibility and testability. IOC allows you to focus on business logic while Spring handles object creation and lifecycle management. The container reads configuration metadata, identifies beans, and wires them together based on your definitions. IOC is especially useful in large applications where managing dependencies manually becomes complex. It also helps in unit testing because you can easily replace dependencies with mocks. In interviews, highlight that IOC is not just object creation but a design mindset where control is given to the framework instead of the developer. Next question: what is dependency injection in Spring? Dependency injection is the mechanism through which Spring implements IOC. Instead of a class creating its own dependencies, Spring injects them from the outside. This is usually done through constructor injection, setter injection, or field injection. DI reduces coupling, increases maintainability, and makes testing easier. When dependencies come from the container, you can swap implementations without modifying business logic. Spring recommends constructor injection because it ensures immutability and makes dependencies explicit. Setter injection is preferred for optional dependencies. Field injection is generally discouraged because it hides dependencies and makes testing harder. In interviews, emphasize that DI supports modular architecture, easier unit testing, and clean code. It is one of the core reasons Spring became so popular. Next, what is the Spring IOC container? The Spring IOC container is the heart of the framework. It is responsible for creating objects, configuring them, managing their lifecycle, and injecting dependencies. The two main container types are the BeanFactory and the application context. BeanFactory is a basic container that provides lazy initialization and lightweight dependency injection. Application context is the advanced container that adds internationalization support, event handling, annotation scanning, and automatic bean post processors. Most modern Spring applications use application context because it initializes beans eagerly, provides better integration with Spring modules, and supports annotation-based configuration. In interviews, explain that the container reads metadata from XML files, Java configuration classes, or annotations to assemble your entire application automatically. Next, what are Spring Beans? Spring Beans are objects created, configured, and managed by the Spring container. Each bean represents a component of your application, such as a service, repository, or controller. Spring decides how the bean should be instantiated, what dependencies it needs, and how long it should live. Beans can be configured using XML, Java configuration, or annotations like component, service, repository, and controller. A bean may have different scopes such as singleton, prototype, session, request, or application. The default scope is singleton, meaning Spring creates only one instance of the bean per container. In interviews, mention that Spring Beans help achieve loose coupling because developers do not manually manage object creation. Next question: what is bean scope in Spring? Bean scope defines the lifecycle and visibility of a Spring bean. The most commonly used scope is singleton, where only a single instance of the bean exists for the entire container. This is the default. Prototype scope creates a new bean instance every time it is requested. This is used when the object contains state that must not be shared. For web applications, additional scopes exist. Request scope creates a new bean per HTTP request. Session scope creates one bean per user session. Application scope creates one bean per web application. Understanding scopes is important because incorrect usage can lead to memory issues or unexpected shared state. Interviewers look for clarity on when and why different scopes are used. Next, what is auto-wiring in Spring? Auto-wiring is Spring's feature for automatically injecting dependencies without explicitly specifying them in configuration. It matches beans based on type, name, or constructor arguments. Spring supports several auto-wiring modes such as by type, by name, constructor, and annotation-based auto-wiring using auto-wired. Auto-wiring simplifies configuration but can cause issues when multiple beans of the same type exist. In such cases, qualifiers or primary annotations help resolve ambiguity. In interviews, mention that auto-wiring reduces boilerplate, keeps configuration clean, and integrates well with annotation-based development. Next, what is the difference between BeanFactory and application context? BeanFactory is the basic Spring container. It provides simple dependency injection with lazy bean initialization. It loads beans only when they are requested. Application context is a more advanced and feature-rich container. It supports event publishing, internationalization, annotation scanning, and bean post processors. It loads all singleton beans during startup, which improves performance at runtime. Most modern applications favor application context because it integrates better with Spring MVC, Spring Security, and Spring Boot. Interviewers often ask this question to check if the candidate understands Spring's internal architecture. Next, what is Spring? AOP. AOP stands for Aspect-Oriented Programming. It allows developers to separate cross-cutting concerns such as logging, security, transactions, metrics, and auditing. Instead of writing duplicate code across multiple classes, AOP lets you write one aspect that applies to many methods. This reduces clutter and keeps business logic clean. Spring AOP is proxy-based and works mainly with method-level cross-cutting functionality. Interviewers expect you to explain that AOP helps eliminate repetitive code and makes applications easier to maintain. Next, what is the role of @component, @service, @repository, and @controller? These annotations are Spring stereotypes that mark classes as components managed by the Spring container. Component is the most general stereotype used for any Spring managed class. Service represents service-level classes that contain business logic. Repository represents data access classes and adds exception translation for database operations. Controller represents web layer components in Spring MVC. Using these annotations helps Spring automatically detect and register beans through component scanning. They also make the application architecture cleaner by clearly defining the role of each layer. In interviews, emphasize that these annotations improve readability, structure, and maintainability. What is Spring AOP and why is it used? Spring AOP stands for Aspect-Oriented Programming, a technique that helps separate cross-cutting concerns from business logic. Cross-cutting concerns are functionalities like logging, security checks, auditing, performance monitoring, and transactions. These concerns tend to repeat across multiple classes and methods. Instead of duplicating such logic everywhere, Spring AOP allows you to write it in one place called an aspect and apply it automatically wherever needed. This keeps business code clean and improves maintainability. Spring AOP uses proxies to intercept method calls and apply additional behavior before, after, or around method execution. It integrates seamlessly with Spring's IOC container, making it easy to apply aspects through annotations. In interviews, emphasize that Spring AOP helps achieve cleaner architecture, reduces duplication, and improves testing and consistency across the application. Next question. What is an aspect in Spring AOP? An aspect is a modular unit that encapsulates cross-cutting functionality. It contains reusable logic that can be applied to multiple methods across the application. For example, you may create an aspect for logging method execution time. You define that logic once, and Spring automatically applies it to targeted methods. An aspect contains advice, Pointcuts, and possibly introductions. Spring AOP uses annotations like aspect to define such classes. Aspects improve separation of concerns by removing cross-cutting code from service and controller classes. Interviewers expect a clear explanation that aspects help isolate repeated functionality, making the codebase more manageable and modular. Next, what is advice in Spring AOP? Advice represents the action taken by an aspect at a particular point in a program. Spring AOP supports several types of advice. Before advice runs before a target method executes. After returning advice runs after the method successfully completes. After throwing advice runs when the method throws an exception. After advice runs regardless of method outcome. And around advice wraps the entire method execution, allowing you to run code before and after and even control whether the method executes. Around advice is the most powerful because it can modify arguments, block execution, or measure performance. Interviewers want you to understand that each advice type serves a different purpose and helps control method execution at precise points. Next, what is a Pointcut in Spring AOP? A Pointcut defines where an aspect should be applied. It is a set of rules that match specific method signatures or class patterns. For example, you may want to apply logging advice to all methods inside the service layer. A Pointcut expression captures that rule, and Spring uses it to determine which methods the aspect should intercept. Pointcuts allow fine-grained control over AOP behavior. Without them, aspects would apply everywhere, causing performance issues or unintended behavior. In interviews, explain that Pointcuts connect the when and where to the aspect logic, making the AOP system precise and efficient. Next question, what is a JoinPoint? A JoinPoint represents a specific point during program execution where an aspect can be applied. In Spring AOP, JoinPoints are method executions. This means advice can run before, after, or around method calls. Spring AOP does not support field level or constructor JoinPoints because it uses dynamic proxies, which wrap method invocations. JoinPoints provide context such as method name, arguments, target object, and return values. This information is useful for detailed logging or auditing. Interviewers look for clarity that JoinPoints represent opportunities for AOP intervention. Next question, what is the difference between Pointcut and JoinPoint? A JoinPoint is a specific event in program execution, such as calling a method. A Pointcut is a filter or expression that selects which JoinPoints should trigger advice. In simple words, JoinPoints are actual execution points, whereas Pointcuts are rules that match those execution points. For example, every method is a JoinPoint, but only methods that match the Pointcut expression receive the aspect. Interviewers expect you to explain this difference clearly because it is foundational to understanding AOP flow. Next, what is weaving in Spring AOP? Weaving is the process of applying aspects to target objects. Spring performs weaving at runtime using dynamic proxies. Weaving creates a proxy object that wraps the original bean. Whenever a method is invoked, the proxy intercepts the call and applies advice according to Pointcut rules. Since Spring AOP uses runtime weaving, it works only on Spring managed beans and only on method execution join points. Mention in interviews that weaving enables AOP without modifying your source code, which makes it flexible and non-intrusive. Next, what is the difference between Spring AOP and AspectJ? Spring AOP provides proxy-based AOP that works only on method execution and only for Spring managed beans. It is simple and suitable for most enterprise applications. AspectJ is a full AOP framework that supports compile time, load time, and runtime weaving. It supports more join points including field access, object construction, and initialization. AspectJ is more powerful but more complex to configure. Spring AOP is designed to be easy, lightweight, and sufficient for typical cross-cutting tasks like logging, security, or transactions. Interviewers expect you to highlight that Spring AOP focuses on simplicity, while AspectJ focuses on richness. Next, how does Spring AOP work internally? Spring AOP works through dynamic proxy creation. If the target object implements an interface, Spring uses JDK dynamic proxies. If not, it uses seglib proxies to generate subclass-based proxies. The proxy wraps the original bean and intercepts method calls. When a method matches a Pointcut, the proxy applies advice before delegating to the actual method. This keeps AOP non-intrusive because your classes remain unchanged. The IOC container manages the entire proxy lifecycle. In interviews, emphasize that Spring AOP works at runtime, method level granularity, and integrates seamlessly with Spring managed beans. Next question, what are cross-cutting concerns and why are they important in AOP? Cross-cutting concerns are functionalities that apply across various layers of an application rather than belonging to one specific module. Common examples include logging, security, caching, auditing, transactions, and performance monitoring. If implemented redundantly inside multiple classes, they lead to code duplication, inconsistency, and maintenance issues. AOP solves this by centralizing these concerns into aspects. Instead of writing logging inside every service method, one aspect can handle it for the entire application. Interviewers want to see that you understand AOP's purpose, keeping business logic clean and modular by isolating repetitive tasks. What is Spring WebFlux and why was it introduced? Spring WebFlux is Spring's reactive and non-blocking web framework built to handle massive concurrency with minimal resources. Unlike Spring MVC, which follows a thread per request model, WebFlux uses an event loop architecture based on Reactor's Mono and Flux types. It was introduced to support modern applications that need high scalability, such as microservices, streaming systems, and real-time applications. Traditional blocking I/O struggles when thousands of users connect at the same time because each request occupies a thread. WebFlux solves this by using non-blocking I/O, making it possible to handle many concurrent requests with fewer threads. In interviews emphasize that WebFlux is ideal when responses depend on asynchronous data sources like APIs, data buses, or message queues. It gives high throughput, low latency, and efficient resource usage. Next question: what is the difference between Spring MVC and Spring WebFlux? Spring MVC is synchronous and uses blocking servlet APIs, while Spring WebFlux is asynchronous and non-blocking. In Spring MVC, each request is tied to a dedicated thread. If the thread waits for a database call or API response, it stays blocked. WebFlux uses an event loop architecture. It never blocks threads while waiting for responses. Instead, it resumes processing when the data arrives. Spring MVS uses Java types and returns objects directly, while WebFlux uses Mono for single results and Flux for streaming multiple results. Use WebFlux when your architecture requires scalability, real-time data, streaming use cases, or cloud-native workloads. Use MVC when your application is primarily synchronous and relies on blocking libraries. Next question: what are Mono and Flux in Spring WebFlux? Mono and Flux are the two core types in Project Reactor, the reactive engine behind WebFlux. Mono represents a stream that emits 0 or 1 value. It is used when your endpoint returns one item, such as fetching a single user. Flux represents a stream that emits 0, 1, or many values, even infinite streams. It is used for lists, streams, or continuous data sources. Both are asynchronous, lazy, and non-blocking. They support operators like map, flat map, filter, delay, merge, zip, and more. Interviewers expect you to mention that Mono and Flux replace traditional return types and enable non-blocking pipelines. Next question: how does the request handling model in WebFlux work? WebFlux follows an event-driven model. When a request arrives, it does not immediately bind it to a thread. Instead, the request is passed through an event loop. If an operation is slow, like a database query or calling another API, WebFlux does not block. It registers a callback and releases the thread to handle other requests. When the result is available, WebFlux resumes the pipeline and sends the response back to the user. Because of this model, WebFlux can handle thousands of concurrent requests using only a few threads. Next, what is the role of router functions and handler functions? WebFlux supports two programming models, the annotation-based model and the functional model. In the functional model, router functions define routes using a functional style instead of annotations. Handler functions contain the business logic to process requests. This style is useful for applications that prefer immutability and functional programming concepts. It also gives precise control over request routing. Interviewers may ask when to use it. Choose functional routing when building lightweight microservices or when you want a more expressive and testable routing system. Next question: how does WebFlux achieve non-blocking behavior? WebFlux achieves non-blocking execution by using the Reactor event loop, reactive streams backpressure, asynchronous non-blocking I/O through NATI, Undertow, or Servlet 3.1 containers. Instead of blocking a thread when waiting for the data, WebFlux registers callbacks. Backpressure allows consumers to control how fast data is produced, preventing overload. WebFlux's entire stack, from a TP layer to reactive database drivers, supports non-blocking operations. Next, what is backpressure in WebFlux? Backpressure is a mechanism in reactive streams that prevents producers from overwhelming consumers with too much data. For example, if a data source emits values faster than the client can process them, backpressure signals the producer to slow down or pause. Flux supports backpressure natively, allowing safe streaming between services. In interviews mention that backpressure improves stability in high-throughput systems where data flow control is critical. Next, which servers support Spring WebFlux? WebFlux supports multiple servers, both servlet-based and non-servlet-based. Netty is the most common choice because it is fully non-blocking and event loop-based. You can also use Undertow, Jetty, or Tomcat with Servlet 3.1 non-blocking I/O. However, using Tomcat reduces some non-blocking advantages since it mainly relies on Servlet APIs. Interviewers expect you to mention that Netty is the preferred runtime for true reactive performance. Next, can we use blocking libraries inside WebFlux? Why or why not? Blocking libraries should be avoided because they break the event loop model. A single blocking call, such as waiting for JDBC operations, will hold a thread and reduce scalability. Instead, WebFlux encourages using reactive drivers such as R2, DBC for databases, or web client for calling external services. If blocking is unavoidable, Spring provides bounded elastic schedulers to isolate blocking code. But in an interview, the correct answer is blocking breaks the non-blocking architecture and leads to thread starvation and performance degradation. Next, what is web client and how is it different from REST template? Web client is the reactive, non-blocking HTTP client in Spring WebFlux. It replaces a REST template which is blocking and synchronous. Web client can handle both single responses and streaming responses using Mono and Flux. It integrates perfectly with WebFlux for reactive end-to-end pipelines. REST template holds a thread while waiting for the response, but web client frees the thread and resumes the execution when data arrives. Interviewers expect you to explain that web client is the modern choice for microservices and high-performance applications. So these are the top 10 interview questions and answers on Spring WebFlux. What is Spring Security and why is it used? Spring Security is a powerful and customizable authentication and authorization framework for securing Java and Spring applications. It provides protection against common security threats like session fixation, CSRF, request forgery, and unauthorized access. Spring Security integrates deeply with the Spring ecosystem, making it the standard choice whenever an application needs robust security. It works by intercepting every incoming request, checking whether the user is authenticated, and enforcing authorization rules to decide whether access should be granted. It supports authentication using databases, LDAP, OAuth2, JWT, and custom mechanisms. Developers choose Spring Security because it provides enterprise-level security with minimal configuration. In REST API, Spring Security is essential because it enforces stateless authentication and prevents unauthorized clients from accessing endpoints. Overall, Spring Security simplifies implementing complex security flows while keeping applications safe and production ready. Next question. What is authentication versus authorization in Spring Security? Authentication verifies the identity of the user. In simple terms, authentication answers the question, "Who are you?" It usually involves checking credentials like username and password, validating tokens, or using third-party providers like OAuth2. Authorization, on the other hand, determines what the authenticated user is allowed to do. It answers the question, "What can you access?" Authorization controls access to URLs, methods, and resources based on roles or permissions. Spring Security handles both steps automatically. First, every request passes through authentication filters. If authentication succeeds, authorization checks decide whether to allow access to the requested resource. Interviewers expect you to clearly state that authentication comes first, authorization comes second, and both together form the complete security mechanism. Next, what is the security filter chain? The security filter chain is a series of filters that process every incoming request before it reaches the application. Spring Security uses this chain to apply authentication and authorization logic. Each filter has a specific job, such as validating credentials, checking sessions, parsing JWT tokens, enforcing CSRF rules, or controlling access decisions. When a client makes a request, the filter chain executes in order. If authentication fails, the request is rejected immediately. If it succeeds, the chain continues with authorization checks. The purpose of the filter chain is to centralize request security handling so developers don't manually secure each endpoint. Understanding the filter chain is crucial because Spring Security heavily relies on it, especially in stateless systems like REST API where token validation happens per request. Next, what is UserDetails and UserDetails service? UserDetails is an interface that represents the user's identity and permissions. It stores information like username, password, and granted authorities. Spring Security uses it internally during authentication. UserDetails service is the service responsible for loading user data. When a user tries to log in, Spring Security calls UserDetails service to fetch the user's information from a database or any other storage. This separation allows developers to customize authentication without modifying the security framework. In interviews mention that UserDetails service is essential when integrating Spring Security with custom databases or authentication providers. It lets you map application-specific user models into Spring Security's authentication system. Next, what is password encoder? Password encoder is used to hash passwords before storing them, ensuring that raw passwords are never kept in the database. Hashing makes passwords secure even if the database is compromised. Spring Security provides multiple encoders like bcrypt, scrypt, argon2, and pbkdf2. Bcrypt is the most commonly recommended algorithm because it is slow by design, making brute force attacks harder. During authentication, the user's raw password is encoded using the same hashing algorithm and then compared to the stored hash. This ensures strong password protection. Interviewers expect you to mention that storing plain text passwords is dangerous, and password encoder solves this by ensuring secure password hashing. Next, what is CSRF in Spring Security? CSRF stands for Cross-Site Request Forgery. It is an attack where a malicious website tricks a logged-in user into performing unintended actions on another website. Spring Security protects against CSRF by generating unique tokens. For stateful web apps that use sessions and cookies, CSRF protection must remain enabled. REST API, however, are typically stateless and use tokens like JWT instead of cookies. Because of this, CSRF protection is usually disabled for stateless APIs. In interviews, the important point is that CSRF protects users from forged requests and should remain enabled for browser-based applications but is not required for token-based REST architectures. Next, what is JWT and how does Spring Security use it? JWT stands for JSON Web Token. It is a compact and self-contained token used for stateless authentication. When a user logs in, the server generates a token that contains user details, expiration time, and send back to the client. The client stores this token and sends it with every subsequent request. Spring Security validates the token through filters inside the security filter chain. Because JWT is stateless, the server does not store session data, making it ideal for microservices. If the token is valid, the request proceeds. If not, access is denied. Interviewers expect you to mention that JWT improves scalability, reduces server load, and integrates naturally with Spring Security's filter-based architecture. Next, what is the difference between a session-based and token-based authentication? Session-based authentication stores user data on the server. After login, a session ID is created and stored in a cookie. Every request sent by the browser contains this session ID, allowing the server to identify the user. Token-based authentication, such as JWT, stores no user session on the server. Instead, the token itself contains all required user details. The client includes this token in the authorization header for every request. Token-based authentication is stateless and works well with distributed systems. Session-based is suitable for traditional web applications. Interviewers expect you to highlight that Spring Security supports both patterns, but modern REST APIs prefer token-based authentication for scalability. Next, what is role-based access control in Spring Security? Role-based access control, or RBAC, restricts access to application features based on user roles. For example, an admin may access management endpoints while a normal user cannot. Spring Security simplifies RBAC by allowing access rules on URLs, controller methods, and service methods. When a request arrives, Spring checks the user's granted authorities and decides whether the action is allowed. RBAC ensures security policies are enforced consistently throughout the application. Interviewers expect you to mention that roles are typically assigned when a user logs in and are stored inside user details or inside the JWT token for stateless authentication. Next, what is method-level security? Method-level security allows developers to secure individual service or controller methods using annotations such as pre-authorize, post-authorize, secured, or roles allowed. This adds a second layer of protection at the business logic level, preventing unauthorized access even if someone bypasses endpoint security. Method-level security enables fine-grained control because you can express complex rules directly on methods. For example, you can check whether the logged-in user owns a resource before allowing updates. In interviews, emphasize that method-level security complements endpoint security and protects internal logic. Next question, what is OAuth 2 in Spring Security? OAuth 2 is an authorization framework that allows users to grant limited access to their resources without sharing passwords. It is commonly used for third-party logins such as Google, GitHub, or Facebook login. Spring Security provides built-in support for OAuth 2 login and resource servers. In OAuth 2, tokens are issued by an authorization server, and the resource server verifies these tokens. This separation improves scalability and security. Interviewers expect you to explain that OAuth 2 is essential for modern identity systems, and Spring makes its integration easy for enterprise applications. Next question, what is security context and why is it important? Security context stores authentication details for the current user and is accessible throughout the application. It contains the principal, credentials, and authorities. Spring Security automatically populates the security context during authentication. For REST API, the security context is created per request because authentication is stateless. Developers can use security context to retrieve the logged-in user's data inside service layers. Interviewers expect you to mention that security context holder is used to access the context safely. Next, what is delegating filter proxy? Delegating filter proxy is a special servlet filter that delegates filter execution to a Spring-managed bean. This mechanism allows the application to integrate the security filter chain with the servlet container. It ensures Spring Security filters are applied to every request. Without this proxy, Spring Security cannot intercept HTTP traffic. In interviews, the key point is that delegating filter proxy bridges the gap between the servlet environment and Spring's security framework. Next, what is bcrypt and why is it preferred? Bcrypt is a password hashing algorithm designed to be slow and computationally expensive. This makes brute force attacks significantly harder. It automatically includes salt to prevent identical passwords from producing identical hashes. Spring Security's password encoder uses bcrypt by default for strong hashing. The reason bcrypt is preferred in interviews is because it remains secure even against modern hardware acceleration attacks. The slow hashing behavior improves safety at the cost of minimal CPU usage. You should mention that bcrypt is recommended for all production applications. Next, how does Spring Security secure REST API differently from web applications? For REST API, authentication is stateless, meaning the server does not use sessions or cookies. Each incoming request must contain authentication credentials, typically as a JWT token. CSRF protection is usually disabled because REST API are not vulnerable to CSRF when they do not rely on cookies. The security filter chain validates the token on every request and constructs a security context dynamically. In contrast, web applications use sessions, login forms, CSRF tokens, and redirects. REST API rely entirely on headers, tokens, and JSON responses. Interviewers expect you to explain these differences clearly because architects must design security based on the application type. Next, what is a custom authentication provider? A custom authentication provider allows developers to define their own authentication logic instead of relying on default username password authentication. For example, you may authenticate users via API keys, mobile OTPs, fingerprint data, or external systems. When creating a custom provider, you implement the authentication provider interface and override the method that performs authentication checks. This provider is then registered inside the security configuration. Interviewers expect you to mention that custom providers give a flexibility for business-specific authentication flows. Next question: what is a security configuration class? The security configuration class customizes the application's security behavior. It defines authentication methods, authorization rules, password encoders, JWT filters, coverage configurations, and which URLs should be publicly accessible. In earlier Spring Security versions, this was achieved using Web Security Configurer Adapter. Modern Spring Security uses a component-based configuration style. Interviewers expect you to highlight that the security configuration class controls how the entire application is protected and is one of the most important files in any secured system. Next, what is CORS in Spring Security? CORS stands for Cross-Origin Resource Sharing. It allows requests from different domains to access the API. Browsers block cross-origin requests by default for security reasons. When building REST API that serve front-end applications like React or Angular, CORS must be enabled. Spring Security allows configuring CORS at the filter level, ensuring legitimate clients can communicate with the API. Incorrect CORS configuration often leads to blocked API calls, so understanding it is important in interviews. Next, what is exception handling in Spring Security? Spring Security provides centralized exception handling for authentication and authorization failures. When authentication fails, an authentication entry point sends an appropriate error response such as unauthorized. When authorization fails, an access denied handler returns forbidden responses. This ensures clients receive clear, consistent error messages instead of server errors. Interviewers expect you to mention that exception handling enhances API usability and helps maintain predictable security behavior. Next, how do you secure specific endpoints in Spring Security? Spring Security allows restricting endpoint access based on roles, permissions, authentication status, or custom rules. You can define which endpoints require authentication, which should be publicly accessible, and which require specific authorities. For example, admin-specific actions can be protected while allowing public access to login and registration endpoints. Securing endpoints ensures that internal resources are never exposed to unauthorized users. Interviewers expect you to say that endpoint security is the backbone of any secure REST API. What problem does Spring Boot solve compared to traditional Spring framework? Spring Boot solves the problem of complex setup and configuration that exist in traditional Spring applications. In old Spring projects, developers had to configure many things manually, such as XML files, dependency management, server setup, and bean wiring. Even creating a simple REST API required a lot of configuration before writing actual business logic. Spring Boot simplifies this by providing auto configuration, starter dependencies, and an embedded server. Auto configuration means Spring Boot automatically configures beans based on the libraries available in the class path. Starter dependencies group related libraries together, so developers do not need to manage versions manually. The embedded server allows applications to run directly without deploying WAR files to an external server. Spring Boot is not a replacement for Spring. It is built on top of the Spring framework and uses the same core concepts like dependency injection, beans, and application context. The difference is that Spring Boot reduces boilerplate and speeds up development. In real interviews, experienced developers are expected to explain that Spring Boot improves developer productivity, reduces configuration errors, and supports microservices and cloud deployments. Interviewers want to hear how Spring Boot helps teams build production-ready applications faster while still keeping full control when customization is required. Next, how does Spring Boot auto configuration work internally? Spring Boot auto configuration works by examining the application environment at startup and automatically creating beans based on predefined conditions. When a Spring Boot application starts, it scans the class path to check which libraries are present, which beans already exist, and what configuration properties are defined. Internally, auto configuration is enabled using the AT-enable auto configuration annotation. This annotation loads many auto configuration classes listed in Spring Boot's internal configuration files. Each auto configuration class is protected by conditions. These conditions decide whether a configuration should be applied or skipped. For example, if Spring Boot detects that Spring MVC is on the class path, it automatically configures the web layer components. If a database driver is found, it creates a data source automatically. If a developer defines their own data source bean, Spring Boot backs off and does not create the default one. This behavior is called conditional configuration. It ensures that auto configuration never overrides developer-defined beans. In real interviews, experienced candidates must explain that auto configuration is smart defaults, not magic. It works only when conditions match and always allows customization. This design makes Spring Boot flexible and safe for large production systems. Next question. Explain the complete startup flow of a Spring Boot application. When a Spring Boot application starts, it follows a clear and predictable startup flow. First, the application entry point runs and initializes the Spring application. At this stage, configuration sources such as properties files, environment variables, and command line arguments are loaded. Next, Spring Boot prepares the application context. It scans the class path, detects components, creates bean definitions, and applies auto configuration. Dependency injection happens during this phase, where beans are created and wired together. After the application context is prepared, Spring Boot starts the embedded server such as Tomcat. At this point, the application is ready to accept HTTP requests. Once the server is running, lifecycle callbacks like startup runners are executed. These are often used to load initial data or perform startup checks. Finally, the application enters the running state and waits for incoming requests. If any exception occurs during startup, the application fails fast and shuts down. In interviews, experienced developers are expected to explain where configuration loading happens, when beans are created, and when the server starts. Interviewers also check whether candidates understand how to debug startup failures and reduce startup time in real systems. Next question: how does transaction management work in Spring Boot? Explain common real-world issues. Spring Boot uses Spring's declarative transaction management. Transactions are usually defined using the AT transactional annotation. When a transactional method is called, Spring creates a proxy around that method to manage transaction boundaries. The proxy starts a transaction before method execution and commits or rolls back the transaction after execution. By default, Spring rolls back transactions only for runtime exceptions. Checked exceptions do not cause rollback unless explicitly configured. A very common real-world issue is self-invocation. If a transactional method is called from another method within the same class, the transaction does not work because the proxy is bypassed. This causes unexpected behavior in production systems. Another common issue is misunderstanding propagation and isolation levels. Incorrect propagation settings can cause partial commits or unexpected rollbacks. Isolation levels impact data consistency and performance. In interviews, experienced developers must explain how proxies work, why self-invocation breaks transactions, and how rollback rules behave. Interviewers expect real production issues, not just annotation names. Next question: how does Spring Boot handle configuration for multiple environments? Spring Boot supports environment-specific configuration using profiles. Profiles allow different configuration values for development, testing, staging, and production environments. This ensures the same codebase can run in multiple environments without modification. Spring Boot automatically loads configuration files based on the active profile. The active profile can be set using configuration files, environment variables, or command line arguments. This is very useful in CI/CD pipelines and containerized deployments. Spring Boot also follows a strict configuration precedence order. Values provided through command line arguments override environment variables. Environment variables override configuration files. Default values are used only if nothing else is defined. In real interviews, candidates are expected to explain how configuration is overridden, how secrets are managed, and how configuration behaves in Docker or cloud environments. Interviewers want to see that you understand externalized configuration and environment separation, which are critical for production-grade Spring Boot applications. Next question: how do you secure REST API in Spring Boot in real production systems? In real Spring Boot applications, REST API are usually secured using Spring Security. The main goal is to control who can access an API and what actions they are allowed to perform. Every incoming request passes through a security filter chain before reaching the controller. In modern REST API, security is usually stateless. This means the server does not store user session data. Instead, authentication information is sent with every request, usually in the form of a token. When a request comes in, Spring Security validates the token and checks whether the user is authenticated. After authentication, authorization is applied. Authorization decides whether the authenticated user has permission to access a specific API. This is commonly done using roles or permissions. Method-level security is often used to protect business logic. In production systems, additional concerns such as CORS, CSRF protection, and password encoding are also handled by Spring Security. Error handling must be clean so that sensitive information is not exposed. In interviews, experienced developers are expected to explain the request flow, starting from the security filter, through authentication, authorization, and finally to the controller. The focus is on understanding the flow, not writing configuration code. Next, how do Spring Boot microservices communicate and handle failures? Spring Boot microservices communicate either synchronously or asynchronously. Synchronous communication usually happens through HTTP-based REST calls. One service sends a request and waits for a response from another service. Asynchronous communication is used when services do not need an immediate response. In this case, services communicate using events or messages. This approach improves scalability and reduces tight coupling between services. In real systems, network failures, slow responses, and service downtime are common. To handle these issues, microservices use timeouts, retries, and fallback logic. Without these protections, one failing service can bring down the entire system. Another important aspect is service discovery and load balancing, especially in cloud environments where services scale dynamically. Monitoring and logging are also critical to understand failures in distributed systems. In interviews, experienced developers are expected to explain not just how services talk to each other, but how systems remain stable when things go wrong. Interviewers want to hear about failure handling, not just communication methods. Next, how do you optimize performance in a Spring Boot application? Performance optimization in Spring Boot starts with understanding where time and resources are being used. One common area is startup time. Spring Boot loads many components automatically, so disabling unused auto configurations can significantly reduce startup delay. At runtime, database performance is usually the biggest bottleneck. Proper indexing, optimized queries, and connection pooling are critical. Without these, even well-written code performs poorly. Caching is another key technique. Frequently accessed data should not always hit the database. Caching reduces response time and improves system throughput. Asynchronous processing is used for long-running tasks that should not block user requests. Thread pools must be configured properly to avoid resource exhaustion. In production systems, JVM memory settings and garbage collection tuning also play an important role. Monitoring tools help identify slow endpoints and memory issues. In interviews, experienced developers are expected to talk about real performance problems they faced, how they identified bottlenecks, and what steps they took to fix them. Next, how do you handle exceptions and errors in Spring Boot REST APIs? In Spring Boot REST APIs, exception handling should be centralized, not scattered across controllers. Centralized handling ensures consistent error responses and cleaner code. When an error occurs, the application should return a meaningful HTTP status code and a clear error message. Business errors, validation errors, authentication failures, and system errors must be handled differently. A global error handler is commonly used to catch exceptions and convert them into proper API responses. This prevents sensitive internal details from being exposed to clients. Validation errors should clearly explain what input is invalid. Authentication and authorization errors should return appropriate status codes without revealing security details. Logging is also critical. Errors must be logged with enough detail for debugging, but without exposing sensitive data. In interviews, experienced developers are expected to explain error design, not just exception catching. Interviewers want to see that you understand how clean error handling improves API usability, debugging, and system reliability. Next, how do you test Spring Boot applications in real projects? Testing in Spring Boot is done at multiple levels. Unit tests focus on individual classes and business logic without starting the full application. These tests are fast and help catch logic errors early. Integration tests verify how different parts of the application work together. These tests load part or all of the application context and test real interactions between components. External systems such as databases or APIs should not be directly used in tests. Instead, Mock implementations or test-specific configurations are used to keep tests reliable. Test profiles ensure that test environments are isolated from production. This prevents accidental data loss or configuration issues. In real projects, test execution speed is very important. Slow tests reduce developer productivity and are often skipped. In interviews, experienced developers are expected to explain test strategy, including when to use unit tests, integration tests, and how to keep tests maintainable and reliable in large Spring Boot applications. Next, how does caching work in Spring Boot and when should it be used? Caching in Spring Boot is used to improve application performance by reducing repeated and expensive operations such as database queries or remote service calls. Instead of fetching the same data again and again, the result is stored temporarily and reused. Spring Boot provides a simple caching abstraction. Developers enable caching at the application level and then mark specific methods whose results should be cached. When a method is called for the first time, the result is stored in the cache. On subsequent calls with the same input, the cached value is returned directly. Caching should be used only for data that does not change frequently. If data changes often, caching can return outdated information and cause inconsistencies. This is why cache eviction strategies are important. Cached data must be removed or refreshed when underlying data changes. In production systems, different cache providers are used depending on scale. Simple in-memory caching works for small applications. Distributed caches are used for large systems and microservices. In interviews, experienced developers are expected to explain what to cache, what not to cache, how cache eviction works, and how caching improves performance without breaking data consistency. Next, what is asynchronous processing in Spring Boot and why is it important? Asynchronous processing allows a Spring Boot application to execute long-running tasks without blocking the main request thread. In synchronous processing, the client must wait until the task completes. This reduces system throughput and increases response time. With asynchronous processing, the request is accepted, the task is executed in the background, and the main thread is freed immediately. This is very useful for tasks such as sending emails, generating reports, or calling slow external services. Spring Boot supports asynchronous execution using background threads. These threads are managed by a thread pool. Proper thread pool configuration is critical. Too many threads can exhaust system resources, while too few can slow down processing. Asynchronous processing improves user experience and system scalability. However, it introduces complexity in error handling, logging, and tracing. Exceptions in async tasks must be handled carefully because they do not propagate to the caller. In interviews, experienced developers are expected to explain why async is needed, how thread pools work, and what problems async processing can create if not designed properly. Next question. How does Spring Boot interact with databases and what are common performance issues? Spring Boot interacts with databases using abstraction layers that simplify data access. These abstractions allow developers to focus on business logic instead of low-level database operations. A major performance issue in real systems is inefficient queries. Fetching unnecessary data, missing indexes, or poorly designed queries can slow down applications drastically. Another common issue is improper connection management. Spring Boot uses connection pooling to reuse database connections instead of creating a new one for every request. If the pool is not configured correctly, the application may run out of connections or waste resources. Lazy loading can also cause performance problems. Fetching related data unintentionally can result in multiple database calls. This issue often appears in production, not during development. In interviews, experienced developers must explain how database interaction works, why indexing matters, how connection pooling improves performance, and how to identify and fix real database-related performance problems. Next, How do you monitor and observe Spring Boot applications in production? Monitoring and observability are critical in production Spring Boot applications. Without visibility, diagnosing performance issues or failures becomes extremely difficult. Monitoring focuses on system health metrics such as CPU usage, memory usage, response time, and error rates. Observability goes deeper and helps understand why a problem happened, not just that it happened. Logs, metrics, and traces work together to provide full visibility. Logs show what happened. Metrics show trends over time. Traces show how a request flows through the system. In distributed systems, tracing is especially important because a single request may pass through multiple services. Without tracing, debugging becomes guesswork. In interviews, experienced developers are expected to explain why monitoring is necessary, what should be monitored, and how observability helps debug real production issues. Interviewers look for real experience, not tool names. Next, how do you deploy Spring Boot applications in real production environments? Spring Boot applications are designed to be deployment friendly. They can run as standalone applications with an embedded server, which simplifies deployment. In real environments, applications are deployed using automated pipelines. Configuration is externalized so the same build can be used across environments. Environment variables and profiles control behavior without code changes. Applications must handle graceful shutdown, startup failures, and health checks. These aspects are critical for reliability and scaling. Security, logging, and monitoring must be configured properly before deployment. Poor deployment practices cause most production issues, not code bugs. In interviews, experienced developers are expected to explain deployment strategy, environment separation, and operational concerns. Interviewers want to see that you understand what happens after code is written, not just during development.